together with Savick Ford, we've recently been awarded Kavli Scholar status for 2013 to 2015. Okay, what does that mean? There are a handful of Kavli institutes across the world. They're sort of prestigious places for physics and mathematics research. So they're at Cambridge in the UK, MIT, Chicago. The Institute for Theoretical Physics is in Santa Barbara. What they did was we applied for these scholarships. These are intended to help faculty who don't come from or1 institutions, so people who are teaching undergrads, who are also involved in theoretical physics research. And what they will do is they will pay for you to come to Santa Barbara, they will put you up, and they will encourage you to participate in meetings and programs that are going on. The bottom line for all of this is that science is basically social. Scientists need to get together and talk about ideas and figure things out and say, I think it's like this, and someone else will say, no, I think it's like this because, and then, and it's a give and take of ideas. And together you kind of can create something new. And the idea behind the Kavli scholarships is that they want to help people involved in theoretical physics. We are, in the course of this history of this program, they've been about 100 awards in the last 15 years, and we are the first from a community college actually to be given this award. And I think that part of the reason why they're interested in sort of providing us with this kind of support is because we've really come up with a few new and different and interesting ideas on the theoretical side of supermassive black holes. We've been looking at new ways of observing them, so new ways of detecting some interesting physics that may be going on in the disks around supermassive black holes, and giving a sort of advanced warning before black holes merge together, which would be really interesting to be able to watch. But of course, if you don't know that it's coming, it can be hard to catch. So we've got a paper that we're working on right now on that, and we have a couple of other ideas making analogies between how planets form in disks around new stars and how somewhat lower mass black holes form in the disks around supermassive black holes, and that can actually help them grow, perhaps in a way that people had not recognized before. In addition to being accepted as Kavli scholars, Professor McKernan and I, together with a group of astronomers at CUNY across multiple campuses. The PI is Tim Paglione at York, and we also have involvement from Hunter and CSI and City Tech. Basically faculty from those campuses who are astronomers, as well as Columbia University Astrophysics and the American Museum of Natural History's Department of Astrophysics. We're working together as part of an NSF program, which has been called AstroCom NYC, which stands for Astro Community NYC. And as Barry was discussing, from the Kavli perspective, much of science gets done when we sort of get our heads together in the same room and bang them together until something good comes out. And we wanted to create a community for underrepresented minorities because, basically in the sciences, minorities are significantly underrepresented, and astrophysics is no exception, and we're perhaps a little worse than average. And we have such a great network here that we wanted to provide students at our minority-serving institutions with access to that network. And so it's a structured mentoring program, and it involves students doing a course, 2 courses actually, as well as mentored research projects over the summer. And we got a significant amount of funding from the NSF for this, and we're very excited. We just accepted our first cohort of 5, and that will grow in future years. It's a 5-year program, and we'll see where it leads.